Okay, welcome back. This is 10.1. We're working with these things called radicals. What are they? It's basically going in the other direction, the direction opposite of squaring. So, we're used to this kind of notation by now. 3 squared is equal to 3 times 3. So if you go in this direction, 3 times 3 is 9. Okay. Now we want to go sort of in the other direction from 9 and kind of undo the squaring. So you ask yourself, what is blank times blank is 9. What number, when you multiply by itself, gives you 9? And of course, going this other direction, it's 3. And the notation in this other direction is going to be the root symbol. Okay, and this in particular, there's going to be all kinds of different root symbols, but this is the most famous. This is the square root symbol. Okay. Okay, there's issues with negatives and positives, negatives versus positives with roots, and we need to also deal with that as we go through it. So it's not just as simple as what you may have already encountered with arithmetic and working with perfect squares and undoing them. It's not that simple. We want to talk in more detail now, really get into it. All right, so square roots is what we're dealing with. And of course, this first direction is called squaring. And so if we have 4 squared, that equals 16. And then likewise, if you have something like 5 squared, that will equal 25. Okay, so we're pretty familiar with that. The subject now, though, is the reverse direction, the square root. Okay. And then, you have an undoing process. So you have to kind of think what times what would have equaled this thing right here. And sometimes it doesn't have an answer that's easy to find, but this one is, right? We've already played around with a number similar to 25. Well, exactly 25. So we can undo 25, and what number times itself gives you 25? It's 5, right? So you're undoing. It's just the other direction. So the other case then, if we go in this direction, square root of 16, of course, is just 4. Trying to get this thing straightened out. Okay. So the one issue then, the first issue we see is the principal square root issue. Because in truth, when you go in this direction, there may be more than one answer. And why is that? It's because when you take a number and square it, there's 2 different numbers I'll actually give you, in this case 25. Okay? And you say, okay, well, it's obvious 5 times 5 is 25, but what else? You may, oh yeah, if we include negatives, then if you have negative 5 times, well, okay. So undoing it then, going in the other direction, is kind of unclear. When I want to take the square root of 25, does that mean I want the answer 5? Does that mean I want the answer negative 5? Maybe both. I don't know. How are we going to resolve that issue when we are talking to each other? And that's the principle. We want the principal square root. We want the positive guy. So that's our assumption as we talk and go through math, is if you see this root symbol in particular, we mean this guy right here. The principal square root will be this here, not the negative 5, but the positive. My pens aren't working. So this is the principal square root. Okay, if you want the negative square root, it seems kind of weird, but you have to put the negative out in front. I mean, it's weird, but intuitive. It's obvious. It's so obvious, it's kind of hard to explain. So let's just dive into the homework exercises. I think that's the best way to learn, is just to look at a lot of examples. Anyways, the square root of 16. So you're thinking, what times what is 16? And 4. Okay, that'll flip the bill. and that's the positive one, right? We're not going to put -4. No, this is the principal square root, so we put 4. So how would I ever get -4? How would I ever have that other answer? Well, if you put a negative in front of the principal square root, then obviously it's if you covered up the square root, it'd be, or if you covered up the negative, it'd just be 4, right? But because of the negative there, and then the negative carries over. Okay, there it is. Great, right? All right. Don't get confused here now. If you put a negative inside of the root, that's a whole different story. This guy doesn't have sort of an answer in the numbers that we're used to dealing with. If you've taken a lot of math classes before, you may say, oh, hey, that's imaginary. We're not going to deal with that just yet. Okay, so we're not even going to think of it as equaling something. We'll just, the software will probably give you an option of saying it's not real. Okay. Okay, so when you have a negative under a square root, it's not real. Okay, so back to these other types. We want the negative root of 4 all over 25. Okay, so 2 times 2 is 4, 5 times 5 is 25, so 2/5 times 2/5 would give you 4/25. Okay, and we want the negative version, so we bring that negative over. Okay. Let's look at some other ones that you're going to be encountering if you keep on chugging on with the math programs. 16, we have this guy, 144 plus 25. And then in number 18, they want you to compare and contrast to this 144 plus square root of 25. Okay. And why do I care? Well, it turns out these things are not the same. Okay, and a lot of students will fall into the trap of thinking that they are, but they're not. So you have to be careful in these cases. In this case, you have to kind of work with the 144 and the 25 first. So you consider the radical sign as like a parentheses, and please excuse my dear Aunt Sally, you have to do it the insides first. So I have the square root of 169, and then 169 is a perfect square. 13 times 13 is 169. And for this guy, the square root of 144 is 12. So I just do each one separately, and then plus the square root of 25 is 5. And add those 17. Obviously, it's a different answer, right? So, the main takeaway from here is that this guy and this guy will typically be different answers. I mean, maybe you'll get lucky every once in a while, but not usually. Okay, so just be careful. All right, so now we want to get more abstract, right? We want to introduce variables, just like we did with rational functions, right? So you worked with adding fractions. You went through arithmetic, first simplify fractions, then multiply, divide, add. And then we started adding in variables, right? So, square root, we didn't do square roots yet, but x plus 3 all over 2x minus 1 instead of, yeah. So we want to do the same thing here. We want to introduce some variables, and in particular, we'll consider the square root function, right? So instead of considering square root of some number, we're going to have square root of some variable, okay? So that variable to be determined. The domain of this thing is going to be all real numbers from 0 to infinity. Okay, we can remember from this past example, we can't put negative numbers into a square root. So that's what that domain, that D thing means, this D right here. Okay, and this interval notation, in case you've forgotten, it means I'm going to take all numbers greater than or equal to 0. And those are okay to put in here. So you could put 5 in here, have square root of 5, that's fine. But you can't put numbers from over here, from this side, the negative side of the number line. You cannot put them in here. So the domain is kind of like the acceptable values. What are you going to allow into the party, so to speak? Okay. What are you going to allow into the square root that won't break the square root? So maybe I should define that thing, that domain thing I've been talking about. DOMAIN. So people say they're the king of their domain. Okay, that's your home base, and so that's this side. And then when you put something in it, you get this other part. Anyways, the domain is the possible values you can put inside of a function. Okay, so the process for determining the domain, it turns out to be solving an inequality. So determining your domain. You want to make sure that anything you put inside of the square root is greater than or equal to 0. So if you have some function of x, and inside of here you have a bunch of stuff, like maybe 2x plus 1. So this is an example of me determining the domain. I have to take this stuff right here and make an inequality with 0. I need to make sure that 2x plus 1 is greater than or equal to 0. Okay, so I'll solve this thing, and you solve it just like you solve equations. You're going to first move the 1 to the other side. Then you're going to divide both sides by 2. Okay, and then we can go to our number line and kind of do a graph of it, and that'll help us with our interval notation. If you already know how to do it, then go ahead and write it down, but I'll show you. We want anything that's greater than or equal to -1/2. So we're including -1/2. When you include it, you use a closed bracket. All right? So in this case, the domain, we're starting at -1/2. And we're going all the way to positive infinity. Remember, this is the positive infinity side. This is the negative infinity side. So I go all the way to infinity. With the infinity symbol, I always use a parentheses. And then because I'm including the -1/2, maybe you put a closed dot there. You have to use a bracket. Okay, if you include it, you use a bracket. Otherwise, use a parentheses like this. Okay. Okay, let's look at some examples then from the homework. And here we have 28, and we have f of x is the square root of x plus 2. Okay, so I'm going to take the guts of that function, x plus 2, and say that's greater than, or I need that to be greater than or equal to 0. And now I have to solve this inequality. So I'll subtract 2 from both sides. And x is greater than or equal to -2. On the number line, locate or put a -2. Right? And I want everything greater than that towards the infinity direction. Because of the line, I need to use a bracket or a closed dot, whichever one you prefer. But in your interval notation, you need to use the bracket. Okay? Let's look at another. Here's 32. I have f of x equals the square root of 8 minus 2x. And then I'm going to set up my inequality, 8 minus 2x greater than or equal to 0. So move the 8 over. So I have -2x greater than or equal to -8. Divide both sides by -2. And change the direction of the inequality. Whenever you multiply or divide by a negative, you have to change the direction of the inequality. Okay. Draw your number line, label 4. I want anything that is less than or equal to 4. So the numbers over here would be like 3, 2, 1, 0. 0 is less than or equal to 4. So it must be this side that's shaded. And again, we need to use a bracket. This time we're going towards -infinity. So I'll have negative infinity to 4. Okay, so that's the domain. The next thing we want to do is actually graph one of these guys. Okay, so we've graphed equations of lines. You may have even graphed a parabola. This thing is a little bit like the parabola. It's just kind of tilted on its side and chopped in half. Okay. So anyways, the graphing, obviously you want to identify the domain. And easy enough, you're just going to plot some points from the domain onto the xy plane. So you'll pick some x values in this interval and do a t-table and then plot the points. Okay, so 28 continued, right? We've already done a little bit with 28. I already found the domain, so I'm gonna borrow that information. Okay, so 28, we have f of x equals the square root of x plus 2. I have x plus 2 is greater than or equal to 0. And then, of course, x is greater than or equal to negative 2. So that's our domain. You can do a number line. If that helps you draw or write out the interval, that's by all means, please, please, please do. It'll save you points. Okay, and then I'm going to do a t-table. Okay. I'm going to borrow some points from this interval. So anything greater than or equal to negative 2 you can use. So let's try negative 2, and then maybe 0. Well, let's not use 0, and I'll tell you why. If you put 0 in here, you'll have the square root of 0 plus 2, which is just 2. Square root of 2, I can't do that without a calculator, so I'd rather have numbers I can do with a calculator. Okay? So I'm not going to pick 0. I want to pick numbers that will cause a perfect square. Okay? So I can't use 1, that would be 3. But if I put 2 in there, that'll give me 4. Okay? So that's a perfect value for me, because I know the square root of 4. What are some other ones? So maybe 6, or 7, sorry. Because 7 plus 2 will give me 9, and I can take the square root of that. Okay, so let's try these. This will be the square root of negative 2 plus 2. And I simplify that. Square root of 0. What times what is 0? Well, just 0. Let's try this guy. The square root of 2 plus 2 is the square root of 4. And I know that's 2. And finally, 7 plus 2, which is the square root of 9. And of course, the square root of 9 is just 3. Okay, so finally I can go over here to my xy plane. It's going to mainly be in the first quadrant, so I put a lot of room in that first quadrant. Remember, this is a first, second, third, fourth. Okay. So I have, I want to go to negative 2, so 1, 2, and then out to 7. 1, 2, 3, 4, 5, 6, 7. I need to go up to 3. 1, 2, 3. Okay, so you'll have negative 2, 0. And then I'll have 1, 2, 1, 2. And then 7, 3. Okay, I think that's there. And what you end up with is this kind of shape like this. It should be they call it's smooth. It shouldn't have all kinds of bumps in it. I didn't draw it very well. But if you've seen the parabola before, it's basically just half of a parabola. So you just chop off half the parabola, and there it is. Okay? And then, of course, rotated. But that's it. In general, you'll note that square root functions have this kind of shape. Just like, so this would be y equals square root x. Just like equations of lines have certain shapes, right? So y equals x is the diagonal through the origin. It's just straight like that, right? in college algebra, you take a look at all these different shapes and you kind of compile an alphabet based off of the different kinds of graphs. Okay, the next topic is simplifying square roots of something squared. Okay, so simplifying, oof, my battery's on low. I'm gonna plug that in. There we go. Hopefully it did not turn off on me. Okay, sorry about that. My battery was dying. Okay, so simplifying these things, it's a kind of a weird thing. If you have the square root of a squared, it's not going to equal a. Okay, it'll actually equal the absolute value of a. Okay, so why is that? Why do we even care? Well, I don't know. You got to take math, right? But let's consider our function f of x equals square root of x. Okay, we want to consider then f of 2 and f of let's go, geez, sorry, scratch that. Let's consider rather this other guy. Well, just some examples, right? So let's consider the square root of -2 squared versus the square root of 2 squared. Okay. So you kind of have an intuitive sense how this is going to work. The square root of 2 squared is the same as the square root of 4, and therefore the answer is 2. Okay, right? So if you have something squared and you take its square root, the square root and the square kind of undo each other, and you end up where you started, right? So again, if you have maybe the square root of 3 squared, you would expect the answer to be 3, because the square root and the square are kind of what we call inverses, right? So square root of 3 squared is square root of 9, and that's 3. And again, you see, well, the square root and the square root symbol and the little 2 symbol kind of cancel each other out, so that you're just left with the 3, right? And okay, that's fine. But then somebody comes along and they notice, hey, this won't work with negatives. If I put -2 in there and I square it, certainly it's equal to not -2 like the other cases. It's not a case where I can scribble out the square root and then scribble out the 2 and the answer is -2. No, it won't work that way, right? The square root of -2 squared is the square root of 4, which is 2. So you can't play that game. And so we have to have this formula, okay, sadly enough. So whenever you deal with the square root of something squared, you have to rewrite it with an absolute value at the end. So 36, for instance. The square root of -10 squared. Okay. So we're not going to write -10 as our answer. We have to take the absolute value of -10, and that's equal to 10. Okay. Of course, this is kind of the answer you would have gotten anyways if you had just worked it out. The square root of -10 times -10 is 100, and then the square root of 100 is 10. Okay, so you're like, oh, well, so this is just some phony baloney cerebral stuff that nobody cares about. But the troublemaker is when you start working with variable expressions and you kind of don't know if this thing is positive or negative. So you have to hedge your bets. You have to say, well, I can't just work it out. I can't FOIL it and then take this. It's not going to work like this. I have to kind of use the absolute values. So the square root and the little 2 will cancel each other out, but I can't just write x minus 2. You have to include the absolute value. Okay? So let's look at a couple more, just so it's obvious. This one I have to rewrite this in the form of something squared. Okay, so it would be 9x squared squared. So if I squared that, it would be 9 times 9 is 81, and then x squared times x squared is x to the 4th. So at the end then, I could pull out the 9x squared, and I have to put, well, you're supposed to put it in absolute values. This one is kind of weird too, because you may be thinking to yourself, well, anything squared, Dave, is positive, and 9 is positive, and the absolute value of something that's positive won't change it to anything else except a positive. So truthfully, yes. In the end, it's just plain old 9x squared. Okay? And but you know, it's probably safer just to leave those absolute value symbols in there for now until we get, until we get a little more experience. Let's look at one more, and then we'll look at cube roots. We have x to the x squared plus 14x plus 49. Okay. So I could rewrite that as x plus 7 times x plus 7. And of course, that's the square root of x plus 7 squared. And then just like in 38, the square root and the square go away, but you have to use absolute values because of the variable. And we don't really know what's in there. Okay, let's take a break here, and I'll come back in the next video, and we'll finish up the rest of 10.1.